Hello, ladies and gents. This time we're going to talk a little bit about orbit and weightlessness. Here's a question that, since I've taught physics for a very long time, I've gotten this question often. And the question goes like this. The moon is it's a little under 250,000 miles away. And the force of gravity, the Earth is pulling on the moon and the moon is pulling on the Earth. And that force of gravity is what keeps the moon in orbit around the Earth. So force of gravity, you and I know, is equal to weight. Okay. Astronauts who are in the International Space Station are about 255 miles up. That is 1 part in 1,000 of the distance to the moon, and yet they float around weightless. Their food, they have a good time, their hair flies all over the place. They're in a weightless situation. Now, weightless would tend to indicate no force of gravity. So what's going on? How can something 250 miles up not have a force of gravity, and something 250,000 miles away does have a force of gravity? Well, the problem greatly is the English language, and we're going to get there, but let's begin by describing how do you put something in orbit. Remember when we talked about projectiles? If I throw a ball, the ball is going to have some horizontal velocity determined by the original velocity that I throw it, and it's going to be accelerated downward by the acceleration of gravity. If I throw the ball horizontally with a bigger speed, it's going to go further before it actually hits the ground. Well, instead of a baseball pitcher, let's say I've got some sort of a fancy schmancy high-powered gun that can shoot rockets, and I send it out with a huge, massive sideways velocity. As it flies through the air and it has this huge horizontal velocity, the acceleration of gravity vector is always going to be downward towards the center of the Earth. That's the direction of the force of gravity. So if I send an object, a projectile, out fast enough, it will actually curve around the Earth a little bit before it actually hits the ground. Acceleration of gravity is independent of sideways motion. So if I have a big horizontal velocity, it can go a long way before it hits. Sir Isaac Newton, back in the 1700s, made a wild and crazy hypothesis. He said, if you could go to a mountain high enough and you had a cannon that could throw something fast enough, this is what would occur. You throw it with a little speed, it would go like that. More speed, go like that. More speed, phew, go like that. And Newton hypothesized that if you could launch something sideways with enough velocity, it would be able to fall all the way around the Earth without actually ever hitting. This sketch right here, the original one without my doodles on it, was from one of the books of Sir Isaac Newton. And so he was hypothesizing putting things in Earth's orbit hundreds of years before we actually tried it back in the 1950s and 60s. So what exactly is orbit? When something is in orbit, it is in a state of free fall. The word weightless is not an accurate description. Yes, the force of gravity between the Earth and the moon can hold them together, but if you take a tiny little spacecraft that is some distance above the Earth, of course there's a force of gravity downward caused by the Earth pulling on that spacecraft, and of course the spacecraft pulling back on the Earth. So this term weightlessness is not a problem of physics, it is a problem of the English language. It's more accurately described as being in orbit, being in free fall, or being in a zero-G environment. Something that would be equivalent to being in orbit, if I could take you and put you in an elevator or a camper and close all of the windows so that you could not look out, and we dropped you from a very, very high altitude, okay? Put you in a little camper, dropped you from a very, very high altitude, and you couldn't see out, you couldn't see the wind, feel the wind rushing by you. As you were falling downward, you would actually be in a state of free fall, and you could not tell the difference. Your frame of reference would be the same in the state of free fall as it would be for the astronauts who are in orbit or falling around the Earth. So we wouldn't do that because you'd have to have a heck of a parachute to stop you in the end. But whenever you see pictures of people up in the space shuttle juggling tomatoes or whatever, it is not because they are weightless. It's because they are falling without hitting. Now, how do we simulate this? It's a lot of money to actually put a mission into space, and this, rotating in all these weird and crazy directions, can be terribly hard on human orientation. So for astronauts, they try and put them through this experience very early so they get a lot of experience with it before they launch them into up in space in a rocket. One of the ways they do it is an aircraft that has the nickname, the Vomit Comet. Now, you can use your imagination why it might be called the Vomit Comet. The inside of this aircraft looks like it has big wrestling mats everywhere they can pad it. And here's what the aircraft does. The aircraft actually flies a parabolic arc, and they fly this parabolic arc so there is negative 1g of centripetal acceleration. Now, we're on the Earth, so there is positive 1g of acceleration of gravity. So if you've got negative 1g, meaning the aircraft is trying to, it's kind of like these negative g's, it's like if you go over a railroad track very, very fast in your car, your little hiney's going to come up off the seat. These negative g's and positive g's, when they add together, they're going to end up being 0 g's. They only get about 2 minutes of time in this 0g environment, but it gives people an idea of what it's going to feel like when they're in that environment. If you have lots of money and you want to do something kind of crazy, there are companies out there that will do this for civilians. My husband and I looked into it. We haven't done it yet, but because it was sort of like, when I looked into it, it was about $2,500 per person. Yeah, no, we didn't do that. All right, I'm going to have you watch a couple of YouTubes that actually show this, and those are kind of fun. We'll see you later.